handle. Let's say I create my function, right? This is my function f1. What is my function s1 does? My function f1 will solve the equation of x, right? This is the equation of x, right? And then give the output as the y variable, right? Give the output y. So this is my function f1. So for you to call this function f1 in your script, what you can do, you say that y1 y or something like y equal to f1 of x, right? This is how you call your function, right? And you define your x equal to what? The plot here, I have my x running from this is my x0, right? To the xn. My xn is 6, right? So x running from the array from 0 to 6. And again, you can choose any step that you want. If you want your graph to look smoother, so your step need to be small, right? So let's choose here I choose is 0 0 1, right? 0 1, right? 0.01 for the step. So this is how you call your function. But MATLAB also help you to call your function by different way. You can call the function by y equal to the f of f1. So what does this mean? This means that this y right now is the reference of the function f1. So my f1 right now is the variable y, right? My variable y. Then if I want to find the value for y, which is for each of the x, for each of the element x inside of the array x, I just need to call y of x, okay? And then I can plot it, right? I have each y variable for each of the x, right? Then I can plot the function. I plotted x, y of x, right? Here is something that you see in the test example, right? So this is nothing but just the color, right? The color for your plot, your line plot. So it's the red color. And for the line width, they will change the size for your plot line, right? Line width can change the size. And then after you call the size option, then you put the size in here, right? Size here too. Okay. You can change the size. You want smaller, you put smaller. You want bigger, you put bigger. That's it. And for X label, you say this. For Y label, you say this straightforward. And then you put the string inside of it. So I have mentioned to you, everything start by the single quotation, close by a single quotation. The thing between it is the string, right? So remember that, right? So this is the string. So then they will label your x-axis as the x, right? They label your y-axis as the y, right? That's everything in this slide, right? So
One
again,
question.
yes,
The first line of code, it says function y. Does that
mm-hmm.
word function do anything?
Yeah. So this you create the function, you
No,
create
no.
function.
Like the literal letters function, like function. If you took that part out, would it still assign
No,
the
no.
F1? No, you need the word.
Yeah, you need the word function. So this is how you define the function. And to create the function, you need to build a new script. You define it as the function. You say it is y equal to f1. So this is the function f1.
Okay, so you write function, then
Mhm,
some letter or
mhm.
some variable, and then you write what you want to assign to it.
No, this is not sum. This is your output. Okay. So the
Okay,
output, yeah. So that's it. Yep. So this is the output of your function. The output is y, right? And the name of your function is f1, and the s is the input of your function. Okay, clear? Clear? All right, good. Then next, I want to introduce the function for the zeros. For MATLAB, they already have the function f0. You can use f0 to find the zero of the function of a single variable. The syntax for it, you use the function f0, and then you enter the function of the equation that you want to solve, right? So this is your function of the equation that you want to solve. And then you enter the value x0. This x0 is your supply, your guess for the zero. Let's say I have this function, right? Let's say I have this function, right? And is zero is here. Let's say I guess it's a 2, right? Let's say I get it's 2, so I put the x0 is 2 here. Let's say I just guess it, okay? I just guess it. That's how the syntax look like. And the f0 function, we return the value of x that is near to x0 that give you the zero of the function. Okay, they will return if I get this is 2, but it's not 2, so they will give you the exactly value of x that has the zero value of the function. Okay. And here I have the example again. I want to have the zero for the function cosine, right? Cosine, and 2 here. This is radian, right? This is radian. Because it's radian, so it's returned me the value near the 1.5 that give me the f of cosine, f of x of equal to cosine of x, right? They give me the value x near to this radian that give me this f running to 0. Okay, that's how it works. Now come another example. I give you the equation, the polynomial equation. This one. So to what I explained to you, that you create the function, right? In the new script, you say is the output is y, the name of the function is f1, and the input is x, right? My x is running from 1 to 5, right? So my x is the the array running from 1 to 5. And in here, what step I choose? I choose pawn 1 step, right? I choose pawn 1, then I plot it, right? Now I have this equation, I plot it. I can see that for 0 values of it, and see that it has two 0, right? The first one is the minus 0.5, right? The second one is 2.88, right? Then now I want to test the exactly or the accuracies of my f0, right? I can use the function f0. So I say the f0 of f1 here, right? What I can do, I call the function. When you call a function, you use the function handle, right? Function handle f1, and then the x that you get it to have the 0, right? Let's say this one we know right now is minus 0.5, right? Then I give minus 0.5 here, right? Then the MATLAB will give you the exactly number that have the value of 0 of function of 0 here, right? Then they should give you something similar to this number, right? But now I want to introduce you to another way that, so if any one of you don't want to build a new script, to build a new function, you can use this way, okay? So why this way, you define y1 as the variable, right? And y1 is the function of x, right? Y1 is the function of x, like this, right? After that, you just enter the function, you just enter the equation of x like this, okay? So it means that right now y1 is the function of x. You don't have to create a new function like this. Then what you need to do, because y1 is function of x, then you just need to call y1 of x, okay? Y1 of x. So the result of this one and the result of this one should be the same, okay? Then I test it for both of them, right? Like the x1 is the first one that I've explained to you. Now I want to test the f